Many of my students over the years have experienced difficulty with interval notation. Let's try to clear up any confusion remaining. First, let's review inequalities by considering a few examples. The inequality x greater than 1 denotes all real numbers that exceed 1. The inequality x less than or equal to 3 denotes all real numbers up to and including 3. Sometimes we say that x is at most 3 in this case. The inequality -4 less than x less than 3 denotes all real numbers between -4 and 3. In general, the word between does not include the endpoints. On the other hand, the inequality 2 less than or equal to x less than or equal to 6 denotes all real numbers between 2 and 6, including the endpoints. We use the adjective inclusive to indicate that the endpoints are included. It is possible to include one endpoint but not the other. The inequality -3 less than or equal to x less than 1 denotes all real numbers between -3 and 1, including -3, but not including 1. Now let's review how to graph inequalities on a number line by considering a few examples. The graph of the inequality x greater than 1 is given by shading on a number line those values that satisfy the inequality. We use an open circle at 1 to indicate that this value is not included, then color or shade all values above or to the right of 1 on the number line. The colored or shaded arrow at the end indicates that the shading continues indefinitely to the right. The graph of the inequality x less than or equal to 3 is given by shading on a number line those values at or below 3. We use a solid circle at 3 to indicate that this value is included, and then color or shade all values below or to the left of 3 on a number line. The colored or shaded arrow at the end indicates that the shading continues indefinitely to the left. The graph of the inequality -3 less than or equal to x less than 1 is given by shading all numbers on the number line between -3 and 1, including a solid circle at -3 and using an open circle at 1. Let's now review and emphasize some practices about how the endpoints are handled in inequalities. There are two main cases. The first case is when an endpoint is included. In this case, we say the inequality is inclusive and use either less than equal to or greater than equal to. When an endpoint is included, a solid circle is used on the graph. In interval notation, we use square brackets to indicate that an endpoint is included. The second case is when an endpoint is excluded. In this case, we say that the inequality is strict and use either less than or greater than. When an endpoint is not included, an open circle is used on the graph. In interval notation, we use parentheses to indicate that an endpoint is excluded. Let's now consider interval notation via a series of examples. We will summarize interval notation in general at the end of this video. First, let's consider the statement that x is less than 2. The inequality notation is obvious with the wording of the statement. The number line graph shows an open circle at 2 and shading below or to the left of 2 with an arrow indicating continuation indefinitely to the left. Interval notation consists of two symbols in numerical order with either brackets or parentheses to indicate whether or not the endpoints are included. In this case, we have open parentheses, negative infinity, comma 2, open parentheses. The symbol negative infinity indicates that the set has no lower limit. We always use open parentheses with infinity in unbounded intervals. We also have open parenthesis at 2, since 2 is not included in the solution to the inequality. Let's consider a second example for more clarity. Consider the statement that x is at most negative 1. This means the largest that x can be is negative 1. Since x can equal negative 1, we use the inequality x less than or equal to negative 1. The number line graph is similar to that of the previous example, with the major difference being that we use a solid circle at the endpoint negative 1. The interval notation is also similar to the previous example, except we use a square bracket at the endpoint negative 1 to indicate that it is included in the solution set. We never use square brackets with the symbols plus or minus infinity because these symbols do not represent real numbers. Instead, they are used to represent the continuation of the solution set indefinitely to the right or the left on a number line. Moving to a third example, consider the statement that x is at least 2. This means the smallest x can be is 2. The inequality x greater than or equal to 2 represents this statement. The graph has a solid circle at 2 and shading to the right with an arrow indicating the continuation indefinitely to the right on the number line. This time the interval notation is square bracket 2, comma, infinity, parenthesis, with a square bracket at 2 and an open parenthesis at infinity. It is important to recognize that in interval notation, the symbols are used in numerical order from left to right. Also note that if we said x exceeds 2, we would not have included the endpoint and would have used parentheses on both sides of interval notation. Now let's consider some examples where the solution set is bounded and does not continue indefinitely on the number line. Consider the statement that x is between negative 2 and 3. Recall that the word between usually means strictly between the two values. Therefore, we use the strict inequality, negative 2 less than x less than 3, to represent this statement. The graph of this inequality has open circles at both negative 2 and 3, with shading between those values. The corresponding interval notation is open paren negative 2, comma 3 paren, with open parentheses on both ends since neither endpoint is included. If we want to consider the statement that x is between negative 2 and 3 inclusive, then we want to include both endpoints. The inequality negative 2 less than or equal to x less than or equal to 3 represents this statement. The graph is similar to the previous graph with solid circles at negative 2 and 3 since these endpoints are included. The corresponding interval notation is square bracket, negative 2, comma 3 bracket. We should note that it is possible to include only one of the endpoints, in which case the interval notation would have one square bracket and one open parenthesis. In general, we can summarize all the options for interval notation. Assume that A is less than B so that we know A lies to the left of B on a number line. This table gives the options for inequalities and the corresponding interval notation. The first 4 lines indicate unbounded intervals. These intervals continue indefinitely in one direction or the other. Coincidentally, the interval parenthesis negative infinity, comma, infinity, parenthesis, indicates the set of all real numbers in interval notation. The last 4 lines in the table show all options for bounded intervals. We saw examples in which both endpoints are excluded and in which both endpoints are included. The other 2 options for including one endpoint and excluding the other are also shown in the table.